Okay, so what we're going to be doing is we're going to be trying something new. Um, we're going to be working with the videos, and one of the things along with the videos is that at any point in time you can rewind if you didn't understand something, or if you wish to try and work a problem ahead of time, you can always pause the video, work the problem, and then hit resume. And I'll try and leave some auditory pauses in there so that way you would know kind of when to do that. We're talking about factoring polynomials, and which is just to kind of tie in things that we've been doing up to this point. Is beforehand we've been taking things like the roots and multiplicities and just values, and from that we've been building graphs, looking at things like the leading coefficient and determining its end behavior based off of the degree of the polynomial. And from that, we've been going from the numbers to the graph. So like in this case, I have 4 listed roots, and so we're going to assume degree 4, which means it's going to be some form of ax to the power of 4. There's nothing in this to indicate that a is anything other than 1, and so we assume that this is x to the 4th, which we know by using the degrees that it has to start positive and then end positive as it moves off in the positive x direction. We also know that based off of the 2 and the -1, they both have a multiplicity of 1, which means that they are going to intersect the graph at these 2 points. And then we see 2 twice, which means that there is a multiplicity of 2, which means that we're going to see a reflection. And so what we have is a graph that in some nature is going to look like what I've drawn here. We may have to play with the values a little bit and the window, but ultimately we're going to see that graph. If the roots were these values, then I'm taking the opposite of the roots, and then those become my factors. And so this is x plus 2, x plus 1, and then x minus 2. But since it's twice, then it's squared, and that's that multiplicity property. So if I go into a graph and graph these different factors, just as we had them written, then we get, overall, we get the graph that, we said that we were going to get. It looks somewhat, and as it turns out, I didn't even have to scale this one. And we also see our roots, and this is one of the reasons that I really like using Desmos, is that you can just click on the graph and you can see your different roots. And so that's a lot of what we've been doing up to this point, is from the information given, can you then back your way up and get things like the graph? Can you get to the function? If I needed to, to get to the function, I would just, multiply these binomials together. That's going to give me x squared plus 3x plus 2. And I would square this one. That's going to give me x squared minus 4x plus 4. And then I would take those 2 trinomials, multiply them together, and eventually I would get my full function. But now we're going to take this and do things just a little differently, and so now we're going more so into that factoring process. But what are we doing by factoring? We are heading towards solving the different polynomials, and this is where it's going to change just a little bit. And what I'm going to do this first time for this particular polynomial is different from what we've seen before, and I'm going to take a really long time and be very thorough with this polynomial, so that way there's going to be things that make more sense later on. And so the first thing that I would say whenever you're talking about factoring, whenever you're talking about finding the solutions or solving a polynomial, my first step is, I would say, graph. And I happen to have these graphs ready. So when I go to the graph, I see the graph. I'm not entirely concerned with how this thing looks. You know, if I wanted to, I could try and you know, make this graph fit a little bit better. But what I'm looking for is I'm looking for the roots, the x-intercepts, where it crosses the x-axis, and I see them at -4, 1, and 4. But if we go back to our fundamental theorem of algebra, it says that degree in polynomial have in complex roots. We have a degree 4 polynomial. That's indicated by this x to the 4th up front. But I only see 3 roots. But if I remember my rule for multiplicity, and if you look on the left side, down at the bottom you see -4, but you see a reflection, not an intersection. That is indicative of multiplicity, of an even multiplicity, and in this case 2, because that makes up our 4th. But even if you don't remember all of those things, as we work through our solution, it's all going to come up anyway. And so what we're going to do is we're going to use a series of graphing and synthetic division to help us get to our answer. So I want to remember that -4, 1, and 4. And so I'm just going to, we know x is equal to -4. Was it +1? Or was it -1? No, +1. So here's -4, 1, and 4. And I'm just going to start with the synthetic division. Because of the size of some of these numbers, I want to hit some of the larger numbers first, and so I'm going to start with this with the -4, and that's my root. That's my root, and so I can just I can write the number -4. If x equals -4 is my root, 0 x-intercept or solution. If I set this whole thing equal to 0, so I add 4 to both sides, I get x plus 4 equals 0. This x plus 4, as long as I get a 0 remainder, is going to be one of my factors. So now I look at the coefficients. So I have 1, 3, -20, -48, +64. So I set up the synthetic division. And I'm just writing out all of the coefficients. I need to get rid of this. 40. And then I use the synthetic division. So synthetic division says bring down your first term. So that's a 1. And then you just start multiplying. You multiply this number by the number inside the box. So 1 times -4 is -4. -4 plus 3 is -1 times -4 is 4. -20 plus 4 is a -16 times -4 is positive 64. And so let's see here. 48 plus 2 is 50, plus 10, that's 12, that's 60. So what, 16. So this is again 16. And then 16 times -4 is a -64. There's my 0 remainder. So that means x minus 4 is a root, and x plus 4 is a factor. And if you remember, so we started off with degree 4, so this is now degree 3, 2, 1, and then your constant. And so what this says is that I can factor this down into x plus 4 times and I'm using these values. So that's 1x to the third. Um, and I'm going to erase some of this, so I don't want that too cluttered. So this is 1x to the third minus x squared minus 16x plus 16. And I just pulled these from the coefficients directly up above. And what my next step is when I go back and look at these, then what I'm looking for are identical graphs. And that's what tells me that I have done all of the math correctly. And so I'm going to graph in a new graph. There's my x plus 4. I want to go ahead and change this over into dots. That way I can just I can see everything a little bit better. This was x to the power of 3 minus x squared minus 16 plus, whoa, that is supposed to be to the power of 2. There we go, that's better. Plus, what was it, 16. And that's supposed to be 16x. And I see that the graphs overlap. So that tells me that that these two are indeed the same. So I want to temporarily turn them off. And then what I'm going to do now is I'm going to graph this back half. And so you see a different graph, and that's okay. That's okay. If I zoom in on this sum, then what you see, we found that x plus 4 is a factor, x minus 4 is a root. And so where we had that multiplicity 2, which creates the reflection, we now have a multiplicity 1. And we still see the 1 and the 4. And so what we've done is we have eliminated the need to have to work with this very large equation again, large function, and instead we can work solely with this function, which exists right here. So it's already set up for your synthetic division. That's going to save us a lot of time when having to do all of this work. So I'm going to synthetically divide again. Let me carefully erase here. I'm going to synthetically divide again. Our options for roots were -4, 1, and 4. So I'm just going to pick one, and let's change this up a little bit. Let's go with this +4. That way we can see the effects of the graph just a little bit more. So I'm going to put the 4 here. If this is a root, remainder 0, and we're talking about x equals 4, that means x minus 4 is going to be one of the factors. So drop the 1, start your multiplication. 1 times 4 is 4, minus 1 is 3. 3 times 4 is 12, minus 16 is -4. And -4 times 4 is a -16. And I have that remainder 0. So this x minus 4 is a factor. +4 is the root. And so with x squared plus 3x minus 4. So that means x plus 4, x minus 4, And x squared plus 3x minus 4 is my next, is my next factor. I go back to this graph. I'm going to go back to the two originals. So I can actually clear this one out. I'm going to go back to the two originals and rewrite it. Let's see. What was the rest of it? Plus 3x minus 4. And then they line back up. So now I go to this last part. I see a root at -4, -1. Compared to the original, they are still interacting at the same points, but just slightly different. It's a slightly different graph because what we are graphing are factors of the original. So now I have my -4 and my 1. And if you remember how to factor that, you need two numbers that multiply together to give you a -4. When combined together, give you a +3, which in turn will be, let's see here, x plus 4 and x minus 1. That will be how this will factor in the end. But if you don't remember how to do that, you pick one of your roots. So let's go with the root of a +1, just to kind of change things a little bit. So this was root 1. Drop the 1, multiply by 1. 3 plus 1 is 4, times 1 is 4, minus 4 is 0. So there is your x. X equals 1 is a root, so x minus 1 is a factor. And then from here is your x plus 4 is your other factor, which implies that x equals -4 is a root. So now we just graph these last components. We can graph these last components, and let's see here. It was x plus 4, x minus 1. There's the original. And so this will end up being my answer. The last thing to this, and when you are talking about, so I have four different binomials here, and when you talk about ordering, ordering four things. If I told you order the letters A, B, C, and D, there's 24 different ways. There's 24 different ways that you could order these. And so the best way for us to do this is take your roots. Now this time, write out the repeated root. So this would be what our final answer is if I said write out your solutions or your zeros. And when you write out the roots, just keep your factors in that same, following that same order. So your factors, the positives, the numerical components will look to be in descending order, but the roots in turn are positive. And so you could have two ways of representing this answer. First is this, in this format, or you could list it as a square. And either one of these would be considered acceptable. And so this is the process that we're going, this is the process that we're going to be using on the next several problems. I hope this makes sense. If not, you can always go back and look over things. But the next several problems are going to be a little bit harder. I'm going to move through them faster, but it's still going to follow the same pattern.